Okay, this is addition and subtraction of decimals, which is the Louisiana Standard 5 NBT 7. And so we're going to go through a few ways that students can add and subtract with decimals. So the first method that we look at is using these hundreds charts. And so each of these charts represents one whole. And each chart is cut into 100 small squares. So if I'm looking at just the first part of this expression, I would see 2 wholes and 36 hundredths are shaded. And then for the second one, I would see that there's 1 whole and 6 tenths shaded. And another way to write that would be 60 hundredths. And then to find my total, I would say, okay, well, I have 3 full squares, and then I have 4 full tenths shaded and 6 hundredths left over. And on the test, students are going to be presented with something similar to this these charts, and will be asked to list the expression that matches. Okay, so another way that we like to teach students is the arrow way. And many students actually find this one very helpful. So let's say we have 3 and 6 tenths, and we want to add 1 and 4 tenths. So if I'm starting with 3 and 6 tenths, I'm trying to find how to get to the next whole number. And I know that with 3 and 6 tenths, the next whole number is going to actually be the number 4. And so we kind of have to think to ourselves, how do we get from 3 and 6 tenths to that whole number of 4? And in this case, we added 4 tenths. So because we added 4 tenths here, I'm going to break this second digit up and take 4 tenths out. And that leaves me with 1 whole. So I create my second arrow, and I add that 1 whole that's left over. And so I know 4 plus 1 is 5. So 3 and 6 tenths plus 1 and 4 tenths is going to be equal to 5. All right, the student's favorite way to solve is using that standard algorithm. And what we tell them all the time is it's not lining up the numbers like we are used to doing. It's actually lining up the decimals. So we tell students, if you have 3 and 62 hundredths and you are adding 7 and 2 tenths, we would absolutely not write something like this. We're not lining up the digits. And the reason is we are not adding like units for this problem. Because you can see here that the tenths place is being added to the ones place. And those 2 numbers and those 2 units have completely different values. So what we ask students is to line up those decimals. And what I always tell my students is to go ahead and take your decimals, draw a line through them, add your decimal on the bottom. From here, go ahead and separate any of those other units and fill in those empty spots with a 0. Once that's done, they can go ahead and add. So I have 10 and 82 hundredths. But on the test, students will come face to face with something very similar to this, and they're going to have to be able to prove why this student is wrong. And the words like units really need to be included in that answer. So let me show you one other way, or one other method, I should say. It's the number line. And some of the kids like it, some don't. But the important thing is that given a number line, students need to be able to tell what the addition expression is. So I'm going to go ahead and divide my number line up and divide each whole into tenths. So given a number line like so, students may come across a problem that looks like this. And so they're going to have to know, well, we started at 3 2/10, and we added a total of 1 1/10, and we ended up on 4 3/10. So given a number line, students should be able to match the given expression to the number line. Same holds true with subtraction. Arrow way applies still, the standard algorithm applies, number line, everything still applies to subtraction as it does addition. Some students, when given a problem, such as 3 9/10, let's redo that. Sorry about this. Let's say 4 2/10 minus 1 9/10. Some students will actually want to draw their place value chart, and this is a great way to model the problem. So let's say we have our ones place, decimal, tenths place. I'm going to go ahead and draw my line through my decimal here. And I want to go ahead and represent that 4 2/10. So I'm going to have 4 ones, or I'm either going to have the number, or I'm going to actually have the little dots that represent it. And 2/10 here. So given this, I want to go ahead and try to subtract 1 9/10 from that 4 2/10. We always start with the smallest unit, which in this case is tenths. So taking away 9/10 from 2/10 is something we absolutely cannot do. So when we were taught math, we were taught borrow, or go next door and borrow. We do not use that lingo in the classroom. We use the word decompose. So what we're doing is we're telling students, well, 1 1 is the exact same thing as 10/10. And so now that it is decomposed, I can go ahead and subtract 9/10 by crossing 9 of them off, and then taking away a whole number. So I'm left with 2 wholes and 3/10. Just one more strategy. Again, students aren't expected to use certain strategies. Students are expected to be able to see a strategy worked out and know what expression matches that model. On the test, students are mainly going to see word problems. So it's important that they know the step-by-step instructions for solving those problems. So this one says, Susan went to the store with $22.87. She purchased a snack for $2.76 and a drink for $1.79. How much money does Susan have left? So I always tell the students it's important anytime you come across a word problem, read it the entire way through. Then go back, read one sentence at a time, and stop. So Susan went to the store with $22.87. So the first thing I expect kids to do is go ahead and draw that tape diagram. And in this situation, I know that $22.87 represents the total amount that Susan started with. So then I'm going to go ahead and read a little bit further. She purchased a snack for $2.76. So that means she's taking away from that total. So I'm going to make one area $2.76. And she purchased a drink for $1.79. Okay. So again, we're taking away from that total amount of money she started with. And the question is, how much money does Susan have left? So we're going to go ahead and stick in our unknown there. Now, one thing that students often struggle with is the ability to write an expression given a word problem. And that is something that in 5th grade and beyond is an absolute must. So after reading the problem, reading it again, drawing your tape diagram, we go straight into trying to write an expression. And so an expression, the only difference between an expression and really an equation is an expression doesn't have the answer on the back of it. So in this situation, I know I'm going to have to add these two numbers up first. So I'm going to go ahead and take those two and put them in parentheses. And I know I'm taking it away from the $22.87. Now, technically, could we say $22.87 minus $2.76, and then $22.87 minus $1.79, and then add that up? Absolutely, we could do that. Okay, but it's a lot of numbers and it's easy to make a simple mistake. So we're going to stick with this. So we go ahead, we line up those decimals, 2 and 76/100ths plus 1 and 79/100ths. Line them up, draw your new decimal. Go ahead and separate those units so everything's nice and neat. We're not adding the wrong units together. 6 plus 9 is 15, so we're going to put our 5 down and we're going to bundle 10 of those hundredths into a tenth. And that's why we use the word bundling and unbundling, or composing and decomposing, instead of carrying over. And here we have the same thing again. So now that I know the total amount of money that she spent, I can go ahead and take that and subtract it from the amount of money she started with. Again, I'm lining up those decimals. I'm going to draw that line straight through it. I'm separating my units, and I'm going to fill in the holes with zeros. So right to left, 7 minus 5 is 2, 8 minus 5 is 3, 2 minus 4, can't do it. More on the floor, go next door. So instead of having 2 10s, I'm going to unbundle, decompose, and make it this 1 10 turned into 10 1s. And we know that 10 1s plus 2 1s, this is going to become 12 1s. 12 minus 4 is 8, 1 minus 0 is 1. So when Susan left the store, she had $18.32. Students are expected to be able to take this question and turn it into a statement. So how much money does Susan have left? Susan has $18.32 left. All right? All right, thanks for hanging out with me, and if you have any questions,